Thanks. Hi, I'm Basheer. I'm a hardware interface designer at Google, specifically on the VR team. And I was the design lead for the Daydream controller. But before I get too deep into things, I just want to roll back a bit and explain what a hardware interface designer even is, and why I wish more companies would think about this as a specialty. I started off in industrial design school, and there you learn how to design products for manufacturing. It's kind of a mix of art and a little bit of engineering and science, but at the end of the day, it's still pretty solidly grounded in aesthetics and form. And I attempted to redesign a lot of like the normal mundane stuff you'd find around your house. My best friend kind of joked that all of my projects in school were just stuff I saw when I woke up in the morning, like the first day of school, and was like, all right, this is my life now. And that's what I started doing. In reality, it was a lot more organic than that. But one project I did was a digital kitchen timer that still twisted and turned like an analog one. And a lot of that grew from this frustration where when they first gave us this brief, they're like, okay, you can either design an analog kitchen timer where you gut a real one and then you put a bunch of foam around it, or you can find a digital one and then make a foam mock-up that doesn't even work and it just kind of looks like it works. And I was really annoyed because I looked at every single digital kitchen timer, and there were all these like awful grid boxes with these buttons that beep every time you hit it. And then every analog one was like, for the most part, pretty and round and felt good and twisted and clicked. And I really wanted to make a digital one that did that. And they're like, no, you gotta pick one. I was like, no, I'll show you. And that kind of got the wheel turning. Another one was a toaster I made that used a shade of brown to toast rather than a number that you pick arbitrarily on a dial. And as I dug deeper in school, I started figuring out that what I had the most fun with and what I had the most passion about was actually the function and the way it worked. And it was the prototyping and it was the interactions that really had me the most interested. And it was that process of trying to find new, unique ways to communicate digital processes and information to people in a more analog way that was what I was really passionate about. And so I started Googling that, and I found a Wikipedia entry for interaction designer, and I was like, sweet, yeah, that's my title now. That's what I'm going to do. So then I spent like a whole year harassing the really nice people at MailChimp. They're across the street from where I went to school at Georgia Tech. And they let me be their first design intern, and after a long, half-drunk cab ride at South by Southwest, I think I eventually tired them out, and they just were like, okay, fine, you can be our intern. And there we basically just drank artisanal coffee and wore flannel and designed different things for the homepage. One of the things was this sign-in button that got bigger as your mouse got further away from it. That one never launched. And then I had my first experiences at Google. It was still in the user experience design field where I worked on like the sign-in page, which went from blue to gray, which is really cool. And then I worked on like the Pirate Hat app for Hangouts where you can put on the mustaches and stuff. But like the more time I spent in UX land, like the more I felt like I was going to spend the rest of my entire life fiddling with icon placement and Sketch and like making things like snap and then having like weeks worth of meetings on exactly how much internal and external padding the standard material design button should have for users to be the most successful. And honestly, it's really good, honest work that like has a huge impact, but it's just like not even close to what I got jazzed about. And what I had gotten into this thing in the first place was to work on stuff that's kind of one step up from there, where I didn't want to necessarily design the stuff that you put on the screen, but I wanted to decide whether or not we had the whole screen in the first place, how big it should be, where it should go, and what stuff shouldn't be in the screen. And I feel like all that stuff doesn't really get as well considered most times. And I was really into like the knobs and buttons and which ones to use. And both me and like one of my really good friends, Felix, have this like giant box like underneath her desk filled with like 300 buttons and knobs that we like just like fiddle around with like kind of in the middle of the day. And we're like hoping like one day like, oh yeah, one day. But like I care so much about how like they feel and click and twist and how they sound, and neither industrial designers nor interaction designers really work on that stuff, at least not in the traditional sense. So I thought, grad school will solve all of my identity problems. I'll figure it out there. So then I went to the Media Lab at MIT, and it was there that I got into making all kinds of really weird shit like this, where we were constructing our own composite programmable materials, which is like a really fancy title. And then we were kind of giving them life, stuffing them to all hell with sensors, and then kind of seeing what kinds of stuff people could do with them. And when all of that, and that was actually for a car dashboard. And then when all of that wrapped up, I looked around at the job landscape, and I'm like, oh man, I still don't know who I am. And I was like, you know what, screw it. I'll make up my own title, and we'll just roll with it. And I ended up kind of jammed between these two core industrial and interaction design teams we have here at Google. And, left to their own devices and at their worst, and I can't emphasize this enough, like not everyone is like this, but the UX designers are going to try and offload like all of their complex UI stuff that they can't figure out or don't want to mess with, and they want to put that into the physical controller, because then the UX and the UI is really simple and really easy. And then you end up with this like horrifying soup gray box on the right. And then if you talk to all the industrial designers, and when they're left to their own devices and at their worst, they're going to go and try and make this like perfectly rounded, featureless black obsidian box that has like no buttons, and like that's their dream. And bless their hearts, but the Nintendo 64 controller is a classic example of like both of those meshing horribly, horribly, horribly wrong. And I have a lot of fond memories of this thing as a kid, but like, Jesus. What the hell? Like, what happened here? It's a painful physical representation of just too many cooks in the kitchen and way too many meetings. And that rant is kind of how I ended up on the Daydream team, where we sit around all day playing with donut sticks and bagel blasters and half Twinkies. And our team in general is kind of funny because it started off as a complete side project with cardboard. Like, it's not just marketing. It literally was like a handful of people just like messing around with stuff, and where you could put just about like any phone into like the simple box with some plastic lenses and turn it into a VR headset. I think a lot of you have tried it, but I'm not going to like pretend to assume all of you know what it is. But one of the most important things we learned there actually is more meta. It's that like, while VR is really good for gaming, and even to this day, like gaming is a huge subset and a huge category of this stuff, and we've had lots of fun with these games, we still believe that VR is going to be great for so many other things, and it has a lot of potential as a computing platform. And I think for it to be a computing platform, it has to include those new categories. And it's those possibilities that what we believe gives it a fighting chance at being compelling to a huge breadth of people. And so the more we thought about it, the more we realized, like, yeah, cardboard, like, we can't just keep doing that for like years and years and years. And we still believe in it, but I think we needed to offer something a little bit better in parallel. And we need something that was a bit more immersive, a little bit longer form, and a better way for people to interact that didn't have them holding their hand up here the whole time, pressing this one button and clicking on things with their face like they did with cardboard. So last fall, we launched that better, more immersive experience. We called it Daydream. And it's still based upon generally the same concept. Like, you take a nice, smart, highly capable phone like the Pixel, and you shove that into an electronics-free piece of plastic, some comfy fabric and lenses, and that combined gives you a high-quality mobile VR experience. And what you can see is, so we tried to make it feel like it's something that you can actually wear and put on your face. At least it feels a little bit more comfortable, a little bit more approachable. We were kind of dissuaded by a little bit of how a lot of our competitors made these big black boxes. And I totally respect those decisions because it's the fastest way to get there and it's the most efficient way to get there. And us being sort of as a little bit later comers, we really wanted to push it a little bit further and offer something new. And so we have both this headset and this controller that then work together. And unlike before, rather than holding up your hand and clicking on stuff with your face, the input's now a controller, and that you can easily hold and point at, and it connects people to their environment in mobile VR. And this isn't something super new in a sense. Like, the Vive and Oculus both offered this beforehand, but what we were able to do is let you use something like this without having to have any external sensors. And it does come with its own compromises, but for something more mobile, we feel like it was like the right set of compromises. And we spent a lot of time and energy trying to decide what those compromises might be, and we really were trying to create something that was both accessible and simple enough for new users, and something that enables everyone to express themselves creatively and precisely, and then all of that without having to carry around like a bunch of big stuff. And the goal was like something that was just simple yet powerful. And I think we're still working towards that, but I think this is a pretty good first stab. This specific controller, and the reason I'm kind of digging more into it is because a lot of the rest of this talk is about kind of how we made it and the decisions we made. And while even if you don't care about VR or necessarily our own controller, I think I like to use this as a case study to show you that, like, when I give you these more abstract examples of like, here's what you should do when you're prototyping physical products, that I wanted to be able to say, like, in this exact product, here's how those decisions impacted this specific product. And one of the most important and foundational aspects of the controller that really took us a lot of time to really suss out was the fact that you can point in 3D space around you. And to do that, we use a highly calibrated accelerometer, gyroscope, and magnetometer. Sometimes you'll hear that called an IMU, and also like an internal measurement unit. And that combines and fuses data from each of these sensors, and then we know where it's pointed rotationally. And in general, we basically just assume that your arm doesn't work like a robot, and that when you rotate, that your arm kind of pivots around. And so when we show it in VR, it actually moves in VR, even though we only know where it's rotating, because we just assume you're not like doing weird stuff. But before we got to that point in the fall with the headset and the controller and everything all finished up, and before we really tried to build this whole thing out into a proper platform, we didn't have like all these really fancy fabrics, and to be honest, we were super skeptical we could even pull off the fabric stuff. It wasn't until like a few months before launch that we're like, oh wow, I think it's gonna work. And we didn't have any of these fancy Pixel phones, not even like secret ones that like no one even knew. It was just not there. Like we had other phones, but we didn't have the one that we knew was gonna work with our platform. And we didn't have obviously any controllers laying around. And so at the time, at least when we started, this was our input strategy, really in depth. And then what we did have was cardboard, which was like an okay place to start. We could try out some prototypes. And we did have a bunch of these Nexus 5Xs laying around, and these are pretty good for getting started fast. And then we obviously had rooms filled with both assembled and raw sheets of cardboard laying around. And so I kind of rolled in with this super naive question, just asking, and not even in proper English, so don't judge me, it's my personal notebook. Like, oh, what do you guys think about doing a simple Bluetooth controller? And so in school, and at most places, that have a lot of happy-go-lucky engineers, a lot of like creative technologists, and their go-to would be some variant of like, okay, yeah, let's throw an Arduino or whatever trendy Bluetooth, Wi-Fi, BLE, IoT microcontroller of the week is. They'll grab a bunch of buttons, they'll grab a breadboard and some cables, and just get totally lost in building this little marvel from scratch and fill themselves up with all this pride and generate a lot of smiles and like, you know, I get it, it's fun, like I've done that, I've made that mistake so many times, and you gotta go through that. But one of the first things I learned while working for my boss here at Google is that you can get pretty damn far just by buying some crap device on Amazon that does like 75% of whatever it is you're trying to do. And before you've decided whether or not your idea is a fruitful path to go on and to start rat holing on, and before you really know like that you've proven out the heart of your concept, you can do this a lot faster and with a lot less friction and in a form factor you can actually relate to just by buying something that's kind of close. And so for us, specifically, that meant grabbing a fistful of these IM cardboard buttons. They were initially meant to just replace the buggy magnetic switch we implemented in the first version of cardboard. We fixed it later on in the second version where it was kind of like some magnetic conductive fabric. But for this one, all it does is it pairs to your phone over Bluetooth, and when you click the button, it turns into a mouse click. And a mouse click on an Android phone also works like a tap. And it's super ghetto, and it works super reliably and super well. And then we realized that, hey, like you don't have to use the little sticker they put, and you don't have to put it on cardboard, you can just hold it. And so that actually serves as a pretty serviceable one-button remote. And once we lived with that for a few hours and we tried a few demos, we felt pretty immediately good that it was already a compellingly better experience. Like if worst case scenario, we had to switch to plans like D, E, or F and ship just like a one-button remote that literally just did that, it would still be worth making a controller in the first place. And that gave us both the confidence to do the project as well as a crazy reliable working demo that we could use to sell this up the chain. And from there, the major natural inclination is to then turn the rest of this whole concept development phase into like as linear of a process as possible with the understanding that you can come out with a perfect prototype. And in the early stages, this is a terrible idea. Like, especially for anything smaller than your hand, it's just too complicated. And even in like 2017 days, to get all the electronics working at this small of a scale without having to solve, it's just super hard to do that without having to solve a ton of engineering problems that don't even help you validate your idea or your design. And so to get around this, we split it up. And we're not the only ones to do this, but I found this is like a really valuable thing to do. So we split it up into both form prototyping and interaction prototyping. Other people might call it a works like prototype and a looks like prototype. So for other industries, this might be as important where the scales you're working at are really large, but getting the ergonomics, size, weight, and shape of a controller right is such a non-trivial task that if you try and do that at the very end and you're integrating that into your interactive prototype, or you try and do it too early and then you're trying to shove all the electronics in it, you're just going to end up sacrificing one thing or another, and it's really not a good strategy. So if you split it up, let's start with prototyping the form. So it's really easy to get super caught up with sketching and 3D modeling, especially with how much of a fun drug Cinema 4D feels like. You can make all of these kinds of shapes and things, and you're like putting deformers, and you're like like blasting some EDM, and it's like really good. But then, and you can pump them out super quickly, hit print like there's no tomorrow. It's all just STLs, whatever. But it's really, really hard to get a sense of scale correctly. And things that look really sweet and really good on the screen, like some of these weird ear-shaped things, like end up feeling like absolute trash in your hand. You're like, oh my god, this is too thin, or like, oh, this is like really sharp. And it's just really hard to predict that. Even if, and we tried doing this a good amount, like even if you view it in VR and you try and put it like relatively where your hand is, and you're like, like, it's still in real life, like your fingers are very, very sensitive, and it's really hard to understand that without feeling it in the real world. So one thing that I always have to remind myself is start analog and always stay in 3D. So for us, what this means is that we'll ditch the office for a day or two at a time, we'll go to the workshop, and we'll start making stuff with our hands. Sculpey is a pretty solid staple here. It's easy to work with, comes in a huge variety of colors with a bevy of glues, glazes, and doesn't really dry out or get stale. And then when you're done, you just bake it in the oven, and that hardens into a permanent design. And I'm sure there's tons of alternatives out there, like the magic clay and some other stuff, but honestly, the only reason I show this is because it's our favorite, and it's awesome. And we gave a bunch of this stuff to a handful of people on our team, and we tried to get them to imagine what their dream controller would be. This one's called Moon. You touch some of the craters, and then I think it does stuff, but I'm kind of in love with it, which is why I'm showing it, but it's obviously not something we could ship, but one day. And then over time, as we worked with the team and some of the other people to kind of get like a read of the room, we started slowly inceptioning our line of investigation into the mix, and we started trying to see like where we could take it, and then things started getting a little bit closer and a little bit more in the right ballpark of kind of where we ended up with. And so that clay was a really good first start. Then, and I'm kind of ripping this from my industrial design school days, we also like to use polyurethane foam. Colloquially, people will call it sign foam. It's because it's used in a lot of signs. Like anytime you see like 3D letters on a wall, it's like usually filled with this stuff on the inside because it's super lightweight, it's super dense, and it's really rigid. But if you have anything sharp or you got power tools or anything like that, it cuts like butter. A lot of times if I'm feeling really lazy, I'll use like that pocket knife, and it's not as easy, but it works. But yeah, if you got like a bandsaw or jigsaw or anything that's a little bit more powerful, it just slices right through it. And you end up getting some really nice defined particular shapes. Whereas with clay, a lot of times you'll end up with like pretty modeled surfaces, and it's harder to make more geometric things. And then from there, we move towards a bit higher fidelity in the buttons, knobs, and touchpads. And even then, the tendency is to go, okay, no, we're good now. We got this. Like, we can go into CAD. And even then, I still always have to remind myself, like, no, like, you still need to stay, like, keep it physical. And so one thing we do a lot, actually, and that we found a lot of success with is kit bashing. And if you're a model builder or Lego fan or car junkie, you're probably familiar with it, where you buy a bunch of different sets and you just assemble them for their parts. You never build the actual model that's on the box. And there's some models are better for others, but for video game controllers, it's a little bit different. I haven't found like the go-to, like, oh yeah, this is the one we always rip out these buttons from. But there's a lot of neat stuff you can do with it. And so when I joined the team, I asked if I could buy a few controllers for inspiration. And I ended up Amazoning basically every video game controller, TV remote, Bluetooth keyboard, and any other peripheral with a pulse. And I'm really hoping like someone somewhere in Seattle, because on the Xbox controller page, it was like things you might be interested in. And I clicked on every single one and put them in the cart. And I'm really hoping some guy's like, oh, we've done it. We nailed it. But I doubt it. So then this library actually works great as a reference for button layout, force profiles, and more. But in hindsight, it's also worked super great as a like mega grocery store for buttons. And so we started using it for kit bashing. This Neocon controller is kind of has a special place in my heart. They had just figured out how to have a potentiometer that you could twist in a controller, and it came out at the same time as Gran Turismo. So rather than have a stick, because they didn't know how to do that, they just split the entire controller in half, put the potentiometer in there, and then you twist the whole thing, and that's how you drive. And I'm not sure how they decided that was going to be a good idea, but it's pretty fun for like 10 minutes. So then when I'm looking through all of this whole shelf, and I'm like picking up all these controllers, and I'm like basically like grocery shopping for buttons, I've tried to boil this down into 10 characteristics that I look for in different buttons. When I'm at this stage, I'm not always looking for all of these, since a lot of these are a little bit more higher fidelity, and this is generally like when I spec out a button on a controller, this is like I give them just an Excel spreadsheet with like this is what it has to be or else. But I'll look at the size of the individual button, the shape, like do you make it a pill shape, do you make it square, or do you make it the same as the icon? Do you even combine them? Like a volume button or channel buttons are a good example of this, where they're both connected. Do you group them, like on the Xbox or PlayStation controllers? How much is the spacing or the height? Something that's now getting more common is generally more system or home buttons are going to be both sub-flush and also contours, so that they have kind of like this natural language of, oh, it's like a more of a system-y or less used button. And then also playing around with click ratio and click force and travel. And so in this example, specifically, that I'm about to show, which I promise is totally fake, I just made it for this conference, please don't. I grabbed a PS4 DualShock and the Xbox Elite controller, which the Elite controller is freaking awesome. It's a swan song to gamers, but it's also $150. Then you just very carefully, you inspect where all the part breaks are, the screws are, and then you slowly disassemble it, and then you get a nice large pile of pristine components that you can reuse in future ghetto prototypes to come. Then you harvest some of those. You take all don't throw any of it away. You take all the rest, you put it in a big bin, and that bin gets bigger, and it's kind of like if you've ever had way too many Legos, it's like that same bin, and it's glorious. And then you can kind of have like make it rain kind of thing going on if you really wanted to. But then someone has to pick it up, but interns. And then, then I harvested some of these parts, like the O, the triangle, and the D-pad dish buttons. And the triangle is actually pretty cool because if you turn it 90 degrees, it looks kind of like a back button. And then the O already looks kind of like our home button. And so then, you can marry them all together, put it all with some clay, bake that sucker in the oven for like 130°C for 15 minutes. And you have like a pretty serviceable form prototype that you can then feel around, imagine some interactions with. And part of the reason to do this is not just for you. So what you do with this is you then hand it to like 10 other people or 20 other people, or even better, like put it on the table and ask them to pick it up and see, like, do they pick it up the same way you thought? Do they hold it in remotely the right direction? Do their fingers line up in the right spot? And like, it seems like one of those things where you're just going to get really boring data where like, oh yeah, of course they hold it the right way. Like, no, absolutely not. Like, it's a nightmare. Like, everyone just picks it up in like any way whatsoever, and like what seems so clear in your head is definitely not how it works in real life. And this is super valuable. Then, after a few rounds of iteration, you can slowly start to incorporate less and less of the kit bash parts until you get closer to your vision. But even then, one thing we do a lot, so like those little circles, one way to get those to be really nice and look really circular is you actually then take those same button components, instead of putting them in the clay, you then use it as a little cookie tray mold, and then you press it in. And all of that's super representative of one of the main points I want to make here, which is 3D printing isn't always the answer. There's still a lot of fun, analog, creative ways to make stuff. Cardboard and foam core are another good example. They're both super easy to cut, they come in sheets, and they're crazy cheap. In this specific example, I laser cut them for a bit more precision, but you can just as easily hand cut them. And I also layered them kind of like a topographical map style to give them a little bit more body and substance. And then another useful thing that I tend to do a lot, and I think if you had been looking super closely, then you might have seen it on the 3D printed controllers too, but I really like to take notes directly on the controller. I find that it feels cheesy at the time. You're like, oh, like this feels like it's for show. But I promise you, like you come back a month later or 2 months later, and you'll have like no idea what you would have ever said. And so it's useful when you're evaluating decisions down the road, and then it helps you re-understand why you went the design directions that you did. And they're all in context because you wrote them on the controller itself. And this is actually something I kind of ripped from this talk I saw from this guy from DreamWorks, where they would like write notes directly on the frame. And this is kind of like my version of that, but obviously theirs is cooler. And then in these examples, I just hand cut them and then drew the interfaces on, and I would like erase them out and then draw them back on. And you can play with a little bit with like scraping out the foam, and that way you get a little bit of a continuous surface. But there's a lot you can do even just with the foam and just like imagining these sort of different types of experiences. But once you start narrowing down in the concepts, it really starts to feel like your controller prototypes are a little bit dead. And it's a bit hard to get a feel for how hard it is to reach and hit all the buttons. Even if you're imagining it with your thumb, like the fact that you don't feel anything when you hit them really doesn't help you understand like how good they are to reach. So now you got to make it click. One way you can do that is I buy a bunch of raw tack switches from DigiKey, SparkFun, or Adafruit, or you can harvest it from different controllers. But the lowest profile, simplest way to do this that I found is actually you just order the sample kit of snapdomes from Snaptron. You can get it from any other manufacturer, but theirs particularly is a really extensive sample kit, and I've actually not run out of them yet. And they're these tiny little metal domes that just snap when you push down on them. And they have kind of a little pressure point in the middle that if you really wanted to, you could kind of design for, but it's not a big deal. And so what I did, and what I'll often do, is I'll either laser cut or 3D print some plastic controllers just to make sure it's precise, and then I'll tape in with like Kapton tape or even like Scotch tape. I'll tape these little snapdomes in there, and then when you press on the button, it clicks. And just that simple little thing really makes it feel a lot more real. And the closer you can get to that, then the better feedback people will give you when you hand it to them, and they'll actually start to give you more visceral feedback on like, oh, like this is actually really hard to reach. Whereas before, even if when it didn't click, they would just be like, oh yeah, this is fine, like it's all right. So making it actually click, I think gives people a lot more stronger emotional reactions and feelings to it. Then, as you get a little bit higher and higher fidelity in your form development and prototyping, you can then start to make your assemblies a bit more precise and a bit more 3D and fleshed out. And what I like to do is also grab a bunch of Pinewood Derby sticker weights. It's great because they come in like very small increments and they're sticky back, and then you can start putting them inside your prototypes. And that added heft really makes a huge difference. It really starts to make it feel real, because usually when you 3D print stuff, you'll want to make it hollow, or even when you're making a prototype in general, you'll make it hollow so you can stuff things in there. But when you add that weight back in, it really starts to feel like a real controller. And these days, we've now got piles and piles of Daydream controllers laying around. So we actually use those to get up to speed super fast with all the click feel, connectivity, and functionality. And so we heat them up, get them like a fish, and then we take all of that juicy stuff and put it into a newer, shinier, fancier model. But you can do just the same with any other controller that you can get off the internet. And it's similar to one of the points I was making earlier with the one-button click button from I Am Cardboard, where you want to just find something that's super close to the thing you're building, and you can either use it where you don't modify it and use it to build out a really simple interaction model, or if there's sensors or things that they've already implemented with wireless and everything, you can just use that to make a really quick and dirty interactive prototype. And that kind of brings me to the second half of this, where we're talking about prototyping interactions. And in the timeline, don't think of this as something that happens just after what we talk about, but think of it as something that's entirely parallel with what we've been doing. And what I love about doing this way is it's not just for efficiencies, for when like you're waiting on parts or glue to dry or 3D prints to print, because despite all of the marketing, like it still takes like hours and hours and hours for a 3D printer to do anything. And so what I like about this is that despite all of that, it still lets you ping pong between these two different things, and it kind of helps keep me sane personally. And so first off, I guess it's my job as a Googler who's making essentially an accessory for Android phones to say this, but don't underestimate the power of a smartphone. I'm sure a ton of you have at least one old one laying around somewhere. And it's an amazing prototyping tool. And it's deeply integrated into all of these things, a small, wirelessly communicatable, portable, rechargeable package. And from a touch screen that you can use to prototype capacitive features and buttons, to an IMU that you can use for pointing or as a compass, to a proximity sensor, amazing cameras, an LED light. You can even have like a little speaker, and you include all the audio jack, and so much more. And it's all already available to you, both over software and via hardware. And so it's really valuable even if it's something that's like 3 or 4 years old. And so what we did for that is we built our second prototype after the I'm Cardboard button using one of our old phones. And so we made a super simple Android app that just takes all of the data from all of its sensors and everything, and it just sends it over USB. It just shouts it, doesn't do anything else. And then in Unity, we then turned that into a laser pointing menu swiping interface where we're taking in the touch events from the touch screen and then the IMU data to know where you're pointing, and then there's an initial calibration step. And this is basically this plus some of the 3D printed models that we'd made earlier. These combined are what we use to convince the rest of the team that we should ship a controller at all. And that it was from here that they committed to doing the project for real. And so I think by giving someone something where they can really feel what it's going to be like, and then they can also see what it's going to be like, I think both of those combined really helps them imagine in the way that you're imagining what this thing could be and what it might do. And from there, we wanted a bit higher fidelity representation of the touchpad size that we're making in our form models, and particularly because this is VR, and especially because it's mobile VR where we don't know where things are positionally tracked. We can't really show you your controller, you're blindfolded, and you have this thing on your face. we actually made a bunch of laser cut stickers that we can put over on top. I got this 3M material from McMaster Carr. I don't remember the exact name, but you can just as easily use chipboard or cardboard or whatever you have laying around, and you can just hand cut it or you can laser cut it. And if you're specifically interested in this, we actually have all of the templates up online. But what you can do is then pair that with some dedicated on-screen UI, and then it's the actual physical size that we want the touchpad to be, and then the buttons are all in the right spot, in the right position. And it's not exactly the same, but it gets you really close, and now you can start to use this in VR blindfolded, and then developers can actually start to design some of the interactions that they're hoping to get out of it. And we actually ended up using this so much, and because the controller timeline was so tight, that at I/O last spring, before we had models that we could, like actual controllers that we can give to people, we just put all of this online for people to print out, and then all of our developers, like even the ones that were fancy and like had a whole contract with us and stuff, like this is what they built a lot of our games with before they got their initial prototypes of the controller. And it really does get you like 80% of the way there. And then it wasn't until after we got to this point that we then finally were like, okay, fine, I'll put an Arduino on it. I'll actually try and get a more integrated both form and functional model together. And even here, I still avoided some things where I intentionally wired and cabled everything up, and I was using really simple code to just forward all the events along. And that kind of gets me to one of my other points, which is I definitely recommend waiting as long as you can to roll your own board. I know most people probably won't think about that, but even just like asking someone else to design a board, like just wait as long as possible to do that, because it really slows down your iteration time, and it really creates a large list of variables that makes it hard to diagnose, unless you have some like absolute rock star electrical engineer, and then like keep them close, hug them, like don't let them go. But for us, so yeah, it wasn't until now in the process that we finally committed to that. And even then, like you can see it's kind of big. And it's kind of why we called it the garage door opener prototype. And we even had to end up like wrapping it up in cardboard just to make it kind of okay to hold all the buttons and push things. And then over time, we refined that a little bit, and we made it out of plastic with a dedicated Android app so that you could use it one-to-one with a phone rather than through the desktop. And then we used these up until like I would say 3 or 4 months before launch, because it really just got us the vast majority of the way there. And then eventually we started putting some overlays on that touchpad as well so that we can get it down to the right circular size. But all this is to kind of say that you really need to keep your unknowns to a minimum. I think it's tempting to want to really push it and really try and like have this really big perfect prototype. But the more things that you have in there and the more independent variables you have going on, like the more you don't know what's going to go wrong. And in general, even in this prototype too, other than the size, and part of the reason for the size is that we didn't want to challenge any of the recommended design patterns from our touchpad manufacturer. They actually had this whole thing where you needed like a ground plane below the touchpad, and so to get the button underneath that clicks, we actually had to put it all the way down near the bottom, and then we had to cantilever the whole plastic back with a spring and get that to work. And all that's just so that we could just use the touchpad the way the manufacturer said you're supposed to use it, and that way when it doesn't work, we know it's our fault, not theirs, or vice versa, and it helps you suss through some of those issues. And then once that worked, and once we got there, that's when we started finally driving towards making actual form factor complete prototypes, and then started to deeply integrate the components and actually going to having custom pieces in there and custom components that we've designed. But it wasn't like, this is months in, and you can get pretty far without having to do all of that. And that kind of brings me towards the last bit, which is the development side. In the grand scheme of things, we've only really covered the first 20% of the hardware manufacturing process. But when it comes to prototyping, the concept development phase is the most key time to validate and lock your assumptions in. And I don't have a ton of like general advice here, since the process is so crazy different for every project, but I do have 2 things that I personally learned, and I still have to constantly remind myself. They're not that different from what I've been saying so far, but I promise you I have to remind myself of all this stuff so many times, every single time, which is keep it physical. So another example is we're trying to initially the volume rocker on the controller was actually like one big pill shape. There was no divot or anything like that. And we were realizing a lot of people thought it was like just one mega button because it looked just like that. And so we were trying to make a bunch of decisions on a screen during a meeting, and we were like, I don't know, like, are they going to really feel it? And then we're like, okay, no, seriously, we have to just like shut this down. We'll come back, and we're going to actually prototype this out. And so what I did was I went and I took all of our sketches and render concepts. I then modeled them really quick in CAD, and then put them on this big contact sheet with all of the possibilities and things we were considering. Then we spent like some really quality time massaging it with our fingers and kind of narrowing down the concepts. And then on top of that, we also made sure not just to iterate on the physical form as a static piece, but also in combination with various tech switches in order to find kind of like that perfect marriage between the two. And here we've also cut a few corners. So instead of using a real PCB and soldering to it and getting all this stuff, we actually just got a bunch of blank fiberglass board, cut it to like generally the same shape as our PCB, and then super glued all of the components into it, and then created screw mounts so that we could hot swap them out and try different ones really quick. The last thing I also wanted to point out is that despite how far 3D printing has come, getting machined plastic parts can still be super valuable, especially late in the development process, and it's not as expensive as you might think, especially if you have time. So the stiffness, surface finish, and fidelity of the details is really, really hard to match in printing, especially if you want any of these parts in a medium amount of quantity, and machining really brings its A game there. And it's not just for making really fancy metal laptops and parts. You can use it on plastic too, and we did that a ton. And there's a lot of great local shops, especially around the Bay Area, but also in Massachusetts and a lot of other places I've seen. But if you can't find one in your area, fictive, no affiliation, they can actually be a great online accessible solution where they're kind of like Shapeways, if you've ever heard of them, where you can upload a bunch of part files and then they'll actually machine them out and mail them to you. So in our case, we use this to make some really minute final changes to the geometry of our buttons. The nerve endings in your finger are actually crazy sensitive, and we were having problems with people not noticing where the up button was because it's a little bit flush to the surface, and we were wanting to make that icon a little bit easier to feel. And at the point we were at, before we launched, it was actually like 0.1 millimeters or 0.2 millimeters off the surface, and you couldn't feel it at all. And then we tried to print it, and it was like at 0.4 or 0.5, and it felt like it's crazy sharp, and like this is super annoying. And so even just those like 0.1 or 2 millimeter differences were huge. And so getting those machine parts and actually measuring them and testing them was a huge deal for us, and we were able to actually make those final decisions on those parts. And even though you can barely tell it's raised at all in the first place, like your finger can feel all the difference. But anyway, that's kind of just a slice in the process for what it took to get from that page in a notebook to all the way to this kiosk display in the store. And every day I got to remind myself that it's just going to take making like hundreds of shitty controllers that are buggy as hell software to finally get to a prototype that actually hopefully makes people smile. And thanks. You can get in touch either by email or find me on Twitter. I'll be taking questions later tonight between beers 1 and 5. Thanks.